All right, today we're going to use Desmos to run a regression. We've already learned linear, which is y1 tilde mx1 plus b. We've done quadratics, y1 tilde ax1 squared plus bx1 plus c. And now we're going to be doing exponential, y1 tilde ab to the power of x1. All right, question 1. The table shows the number of bacteria in a culture over time, and we're asked to find the equation and predict the number of bacteria after 15 hours. First thing we want to do is open up our Desmos, and we're going to enter in our table. So fill all of your data into the table. Step 2. We're going to go ahead and run a regression. We're going to type in y1 tilde a b to the power of x1. The parentheses are something you can do, you don't have to do. It's a times b to the power of x1, so I just prefer my parentheses. Once you've done that, you'll need to make sure you click on log mode so that your data is accurate to us running this regression as if we were using a TI-84 calculator. So once we do that, they will give us our perimeters, and as you can see, you have your A and your B values. You also can see the correlation coefficients. All right, so once we have our A and B values, we can go ahead and convert A into our values that were given here and our B into the value given here. And again, so we raise this to the power of x when we're writing our equation. So we have our equation, y equals 1,779.4, and then our b value in parentheses 1.112065, and the parentheses to the power of x. Next part asks us to predict the number of bacteria after 15 hours. So we're going to substitute our x value for 15. When we put that in, we will get our value as a long decimal, and we're going to go ahead and round that to the nearest bacteria. So our bacteria is 9,825 because the 7 rounds the 4 up to a whole number. And as you can see, this is a growth because if you notice, all of our values for the y's are increasing. You can also tell it is a growth by our value as our b is greater than 1. Next question is about sea otters. So we have our values of the table showing the number of sea otters living in the bay beginning in the year 1988. We're going to use that data to approximate the number of otters that were in 2018. So it's asking us to find the equation and determine the number of otters in 2018. So step 1, we're going to go ahead and put in our data into a table in Desmos. Once we've done that, we're ready to run our regression. So we're going to type in y1 tilde a parentheses b end of parentheses to the power of x1. Make sure you click on your log mode so that we have our accurate data. Once we've done that, as you see, we have our parameters for our a value and our b value, so we are able to write our equation. Substitute in a value, substitute in your b value, and you have a power of x. So once we have our equation written down, we're going to go to the next part, determine the number of otters in 2018. So we need to see what year would 2018 be, because we're not going to use the value of 2018 as our x. We want to figure out what year that would be. So if you notice, they said that we started in 1988. So in 2018, that would be 30 years later. So our x value, we need to make sure we're using our correct value. So we're going to substitute in 30 into Desmos. So we can substitute our equation in with the value of 30 for x, and it will give us our answer here. We're going to round that to the nearest otter, which would be 74 otter. So in conclusion, we're going to go ahead and put in our table. Sorry, hold on one second. Sorry, I skipped a slide. I just wanted to point out, if you have years in your x values, you'll need to convert those into values that would be appropriate for x values in Desmos before you start your regression. And remember, once you put your data into your table into Desmos and you run your regression, make sure you click log mode so that your data is accurate. And that's pretty much how you run a regression for exponential functions.